Section 14.5, number 47, I think, is the problem that we want to look at. So there's a couple of things going on in this problem. So this problem says, suppose w is a function of x, y, z. They don't say what the function is yet. And we're on a line. So as you move along the, think of it this way, maybe the line goes through space, and as you move along the line, something you can measure changes. It could be, I don't know, electric potential, or it could be heat, temperature, I don't know. But the point is that as I move along this line represented by r of t is at, bt, ct, w changes. W is based on that. And so, you have a couple things going on. Part A says find w prime of t on L. So part A of this problem says find w prime of t on L. L is represented by r of t equals at, bt, ct. So it's pointed in the direction of ABC, some vector, and you just kind of move along. However, you multiply by t, and that's how we represent a line. And here they said w is my function of x, y, and z, right? But each one of these, x, y, and z, if you're going to stay on that line, you basically have parametric equations, right? X is at, y is bt, and z is ct. That's kind of just sitting there for you. And that's why when they say find w prime, you can think of w as a function of t alone, right? I mean, you could kind of substitute in, oh, but here's the problem. I don't know what f is. They didn't give me the function. But the cool thing is, it doesn't really matter. You can still write out a formula for w prime of t using the chain rule. So here I'll do it. All right, w prime of t. So my answer is going to be w prime of t, I know, is the derivative of this with respect to t. But by the chain rule, what is that? That's the partial of f with respect to x times dx dt. Notice I'm using straight d's here because x is just a function of t. Plus the partial of f with respect to y times dy dt. Plus the partial of f with respect to z times dz dt. Okay? So there's w prime of t. And actually I can maybe make this a little bit nicer. Instead of writing partial of f with respect to x, since w is actually that function, maybe it would be nicer to just write this as wx. Is that okay? And dx dt, do we know what that is? Sure, dx dt is just a, because it's at. So times a plus wy times b plus wz times c. Okay? Now parts B and C and D aren't too bad. All they want you to do is, okay, suppose f of x, y, z is equal to some function. So I think in part B, do they make it equal to product? Is that right? Yeah. Suppose it equals x, y, z, and then the answer, then they say use this formula to compute w prime of t. I guess maybe I should have written w, right? Well, no, f of x, y, z is fine. Okay. So then let me skip ahead because, Jesse, you asked me about this 2 days ago now. So I'll skip C and I'll go to D. D says compute W double prime of t, the second derivative. Okay? Now what's weird about that is this. When you look at this formula here, Wx times A, Wy times B, and Wz times C. Okay? You know, another way I could write this, I could put the A in front. A times Wx. But understand, when I write that notation, that's a function of x, y, and z. This Wy is also a function of x, y, and z. Just like W is a function of x, y, and z. And Wz is a function of x, y, and z. And I guess what I'm saying is, if I want to do this, what does this mean? This means compute the derivative of W prime of t with respect to t. So basically, I want to take the derivative of this. Well, that's really complicated. It's like what I just did, but I have to do the chain rule 3 different times. You see that? So let me work that out a little bit so maybe we can follow what's going on. So as I do this, let me kind of follow the format I did last time. Remember I used these partials? Let me do that again. So this is going to equal, I'm going to write A times a big mess. And the big mess is what I get when I take the derivative of Wx. Then I'm going to have plus B times a different big mess plus C times a different big mess. Okay, so what's the big mess? So I guess the chain rule says, when I'm doing the A part, A times Wx, it's going to be the derivative of Wx with respect to, let's say, x times dx dt plus the derivative of of Wx is what I'm working on, with respect to y times dy dt plus the partial of Wx with respect to z times dz dt. That's just this piece. Plus, what's the next thing I need? Partial of, so it's b times partial of Wy with respect to x times dx dt plus partial of Wy with respect to y times dy dt plus partial of Wy with respect to z times dz dt. I think I made these parentheses just a little too close. Plus more. What's the last piece? Take the partial of Wz with respect to x times dx dt. Jesse, is this making sense?
Yeah, I just couldn't, now that I see the dx dt right there, I see where the second A is coming from.
Yes, because
And my original answer, I got the 8, so the 8 squared.
okay, so you see the reason the reason that the other A shows up, like you said, is from right here. That's an A.
Yeah, that's where.
So if I want to express this maybe more simplified, I would say this is A times another A, and then so that's A squared, right? And then this piece here you could write as WXX is the really maybe slick way to write it. And by the way, let me do the same trick here. What's that right there? dy dt? That's b, and here's a b, so let me write b squared wyy. And then let me, again, kind of do the same trick, so you get c squared wzz. And then, if you look at the book's answer, they do this. I think this was kind of cool. They say, wait a minute, what is this? That is wxy, right? But what is this? This is WYX. Right? But remember what I told you about those guys? They're usually equal. And dx dt here, that's A. But dy dt is B. So you see you get AB times this thing, and you also get BA times something that's equal to it. So your book's going to write plus 2AB WXY. And then, you know, you could do the same trick here. So it's like plus 2AC W, I guess you could write XZ or ZX. And then the last piece would be what? Plus 2BC WYZ. There it is. There's W. There's a formula for W double prime of T.